Hi, this instructional video is about quadratic functions. This time we're going to apply the quadratic functions into some word problems, some real life situations. So for example, a nervous diver walks off a platform that is 100 feet over the surface of a swimming pool. 100 feet. Yeah. How long will it take for a diver to reach the water? Now, when somebody walks off a platform, or when something is simply dropped with no additional acceleration applied to it, we have a formula that we use to determine the time. It's given as h is equal to negative 16t squared plus ds. H represents the final height, and the s represents the initial height, and the t is the time. So how do we use this right here? Well, what's given to us is that this nervous diver is walking off 100-foot platform. So that's going to be the initial height. And how long will it take for the diver to reach the water? That's going to be the zero. So we're going to put this formula into a standard form quadratic function as negative 16t squared plus the initial height s is 100. And we're going to let that equal to 0 because that's the final height. Now we're going to use the square root technique to solve this equation. So we're going to subtract 100 to both sides. So we have negative 16t squared is equal to negative 100. And we're going to divide the 16 negative to both sides of the equation. So t squared is equal to 100 over 16. I'm not going to reduce it right now because I'm going to square root both sides of the equation to find for t, because I realize these are perfect squares. So square root of a t squared, the t comes out by itself. And anytime in the past I said anytime you square root any number, there's a possibility it could be a positive or negative. So it could be positive, square root of 100 is 10, square root of 16 is 4, or negative 10 over 4. And 10 over 4 simply has to become 5 over 2, or 2.5. And this one could be negative 5 over 2, or negative 2.5. But in this three-dimensional world, there is no negative time. Time only goes forward, so we're not going to consider that as part of our answer. So how long would it take? 2.5 seconds. That's a long time to scream if you think about it. Imagine 1 1,000, 2 1,000, boom! There it is. So if that makes sense, why don't you try the next one? So why don't you try this one now? A lifeguard drops a lifesaver from 80 feet over the surface of a swimming pool where the same diver is struggling. Help! How long will that take to reach the diver? Why don't you try that? Okay, since it's being dropped, once again, without any additional acceleration induced on it, we're going to use the same formula. H is equal to negative 16t squared plus the initial height s. And this time the initial height is 80 feet. It's closer than where the diver walked off. So we're going to put that in standard form as negative 16t squared plus the initial height of 80 this time is equal to 0, the final height where the swimmer is, the diver is asking for help. To solve this, we subtract 80 from both sides of the equation. So we got negative 16t squared is equal to negative 80. And to solve for t, we're going to divide negative 16 to both sides of the equation. So t squared equals a positive 80 over 16. Let me actually use a calculator to solve this guy. So when I square root both sides of the equation, t is equal to Well, let's go 80 divided by 16. That wasn't too bad. So that's going to be square root of 5. And what's the square root of 5? Well, here I have square root of 5 is equal to 2.24 seconds rounded up. I know it's supposed to be plus or minus, but we disregard the minus time. So here it is. So in the last example, the diver took 2.5 seconds. It's going to get to the diver a little faster at 2.25 seconds. There it is. Okay, now vertical motions sometimes are not just dropped. Sometimes they are thrown. And throwing involves some sort of a speed, a velocity, whether that could be down or up. So for example, here, you throw a foam football downward with an initial velocity of 20 feet per second out of a window to a friend 40 feet below. Yeah, you know you've done this before. Your friend, who was not ready, does not catch the ball. So the question is, how long did it take for the foam football to reach the ground? Now the formula when something is thrown, whether it's up or down, is h is equal to negative 16t squared plus vt plus s. Once again, h is the final height. The s is the initial height from where the ball is thrown in this case. And the t are the times, of course. And the v is the velocity. Now keep in mind that a foam football in this case is thrown downward. So velocity is not only how fast something is going, but also talks about the direction. So the final height, since he missed the ball, the final height is 0. The time is what we do not know. Velocity is 20 feet per second, but it's got to be minus. And the initial height is from a 40-foot window. Okay? All right. So now, if I use that as a standard form, we got negative 16t squared plus v, which is negative 20t, plus initial height of 40. And since the ball is dropped to the floor, to the ground, it's going to be final height of 0. Now, I could identify the a, b, and c and use the quadratic formula, but I want to make it simpler by factoring out the common number, common term, common factor from these three terms. In this case, I'll say it's 4. So 4 times negative 4t squared becomes negative 16t squared. 4 times negative 5t becomes negative 20t. 4 times 10 gives you positive 40. And that's going to be equal to 0. Now using this factored trinomial, I'm going to say a is equal to negative 4, b is negative 5, and c is 10. And I'm going to use the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And when I substitute in all the numbers, I get negative times negative 5, which will become 5, plus or minus square root of negative 5 squared, which will become 25, minus 4 times a, which is negative 4, times 10, all over 2 times a, which is negative 4. Whew! A lot of numbers here. And then when I start evaluating, I get 5. Plus or minus, inside a radical, we are going to have 25, and 4 times 4 is 16, times 10 is positive 160. All over 2 times negative 4 is negative 8. So let's come over here. Then I get 5 plus or minus 25 plus 160 is going to be 185, I guess, 185. All over negative 8. Okay? Of course, and now I could evaluate what square root of 185 is by using my calculator. And that'll make your life easier. So square root of 185. And approximately that becomes 13.6. So let's call it 13.6. So we're going to have 5 plus 13.6 over negative 8, or 5 minus 13.6 over negative 8. And of course, 5 plus 13.6 is going to give me, let's see, what is it? 18.6 over negative 8. Or 5 minus 13.6 is going to be negative 8.6 over negative 8. Now 18.6 divided by negative 8 is going to give me a negative number, which will be negative 2.325, according to my calculator. I already did it ahead of time. But in three-dimensional world, we don't have negative time, so we're not going to consider that as part of our solution. However, 8.6 divided by 8, negative becomes positive 1.075 seconds of hang time. Just above 1 second. What do you think? Okay, so if you thought foam football was kind of cool, so we went to a park and we see a little kids playing a t-ball. So in a t-ball game, a little batter hits a t-ball that is 2 feet off the ground. Yeah, it's a short kid. And hits it at a velocity of 80 feet per second. And using the Newton's law, let's assume that if this kid applies that much force at 80 feet per second, and when the bat makes the contact to the ball will take off at 80 feet per second to carry on that energy. Okay? And the ball is caught by an outfielder at the height of 4 feet. It's a short kid. So how long was the ball in the air? So once again, we're going to go h is equal to negative 16t squared plus vt plus ds. However, this time the final height is not 0. It didn't drop to the ground. It was caught at 4 feet. So h is 4. And we have negative 16t squared plus the velocity carried over from the swing of the bat is going to be 80 feet per second. So 80t plus the initial height of the ball sitting on top of the t stand is at 2. And putting that in some sort of a form, standard form, we get negative 16t squared plus 80t plus a 2 is equal to 4. Now that is not completely in standard form. So we're going to bring that 4 over. So we get negative 16t squared plus 80t minus the 2 equals 0. So from here, we could identify the A, B, and C. Why don't you try finish this up on your own? Okay, so you said A is negative 16, B is 80, and C is negative 2. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Substituting all the numbers, we got negative times 80. Oops. Plus or minus square root of b squared, which is 80 squared. You might want to get a calculator for this guy. Minus 4 times a times c all over 2a. We evaluate, we get negative 80 plus or minus. 80 times 80 is 64 with 2 zeros. 4 times 16 is 64. 64 double that is going to be 128, but it's going to be negative. All over negative 32. So that's going to be negative 80 plus or minus 6,400 minus 128. Real quick. 6,400 minus 128. That gives me 6272. 6272 all over negative 32. And square root of 6272? 6272 is approximately 79.2. 79.2, okay? So negative 80 plus 79.2 over negative 32, or negative 80 minus 79.2 over negative 32. Okay, and finally, negative 80 plus 79.2, let's see, that's going to be, I'm just pretending I'm trying to figure out, but I already did this ahead of time. We get negative 0.8 divided by negative 32. Or negative 80 and negative 79.2, that combines to become negative 159.2 over negative 32. I used a calculator. Okay? And finally, I'm making sure that you guys could see this on the screen. Negative 0.8 divided by negative 32. Let me bring that over here. I'm running out of space. This one is going to come out to be 0.25 seconds. Negative 159.2 divided by 32 comes out to be 4.975 seconds. Now, there are two possible answers, but in reality, can a batter hit the ball, a little kid, in less than a second, a quarter of a second, that goes all the way out to the outfield? I don't think so. Can it be almost 5 seconds? Not really, but this is a made-up story, so this is the good story. This is the good answer right here. Okay? But the point is, vertical motion formula. Standard form, A, B, and C. Plug it into the quadratic formula. And there's your answer. Good luck.